You learn more when you do the lab. In this video, I'll help by giving you some advice on the planning phases for a router on a stick lab. To set the context, I match up all my content here about CCNA with the books, so we're talking about content that matches Volume 1, Part 5, Chapter 18 from the now current book. It's the one with this green bit on the cover that says second edition, and that's where the Chapter 18 reference comes from. By the way, the cover on the left is the previous book, in case that helps you get your bearings. All right, so what are we talking about with this lab? Well, my blog site has a bunch of free config labs, as I call them. They're set up so that you look at some requirements and think about what to do, then implement that in Cisco Packet Tracer. So you can go ahead and do that lab right now. You can listen to this video, but you really could stop and go do the lab. I encourage you to do some free play or exploration once you've done what the lab suggests. The lab goes by the title ROAS, or Router on a Stick Basics 1, and I've got a link here in just a minute. There it is. The end of the URL is CLab, short for Config Lab 120, and there's my blog site domain name at the top. So you can go there, read the lab, do the lab, and I'm going to talk more about the planning part of the lab for the rest of this video. If you want to know more about config labs in general, there's a URL you can check out, but let me give you a quick intro to the idea. On the blog page for a lab, it's all on one blog page. There's a figure, there are requirements, there's an initial config. It's useful to read that. Here I've added this video that goes through the planning process, the intro video, everything that leads up to where you then go configure. Then you really should pause if you haven't already. Download the Cisco Packet Tracer file from the lab's blog page. Open it up. That's your starting point to do the lab. Implement the steps that you think are necessary to meet these requirements. Then go back to the blog page and you can see the sample answer, an explanation as to why, a list of Cisco Packet Tracer issues that might impact how you answer. And then, in this case, I've also got a review video where I talk through what the answer looks like. On the left there, you see a diagram that should look somewhat like what you'd see on the blog page. If you haven't opened the blog page, please do, and you might want to have that open next to this video. And the config is going to happen on these two devices, the router and the switch, with most of the focus on the router, but still you have things to do on the switch as well. So I'm summarizing the requirements, which are a list of bullet points in the blog post for this lab. And I've reworded a bit to simplify just because I don't have space for all the words here on the screen. So what I'm going to do for the next 2 or 3 minutes is go over this list, breaking it down into these 4 sections, talking about the router on a stick config on the router, the IP addressing plan, the VLANs, which is most of the interest down here on the switch, and then a few more bullets with some assumptions about things that are pre-configured for you in lab. So focusing first on the IP addressing. If we look up here at router R1, the router on a stick config is going to be associated somehow with this interface, the physical interface that's connected down to switch 1. But if you remember your router on a stick configuration, it's often not configured on the physical interface. In fact, the lab instructions say use only subinterfaces. But if we think generically about router on a stick config, you need a subinterface with an IP address connected to each subnet that you want to support with this router on a stick configuration. The lab itself, the blog page for the lab says use the lowest address in each subnet. And it also says that the PCs are pre-configured correctly, right? So that you don't have to go do it. But if I'm going to add configuration here, it turns out PCs 2, 3, and 4, they're going to then point to the IP addresses in the router on a stick config as their default router. So you can compare the addresses that are pre-configured there to your planned addresses for your router on a stick configuration. All right, so there's a lot to absorb there from that last minute or two, so you can think about that. But another way to think through a ROAS configuration is to say, all right, I've got this more topologically focused drawing over here. What if I just do a more abstract drawing and I list the subnets? So the subnet IDs and masks on the left drawing are kind of sideways, so it fits the figure. But how about if we just made it more readable? Subnet 10020, 10030, 10040, call them subnets 2, 3, and 4, if you will, down here. And this router on a stick configuration we're going to add on router R1 needs to give it some kind of an interface, probably a sub-interface, with an IP address that connects to each of these 3 subnets. Now let's talk about sub-interfaces. The very first few bullet points in the lab page talks about those, and it says only use sub-interfaces, which to me means don't configure ROAS on the physical interface, which is an option. Only use sub-interfaces. And it also says use 3 consecutive numbers for the sub-interface IDs. And there's another phrase there that says choose the first number to match subnet 2. And I think the statement in the lab page on the blog is a bit vague, honestly, and it might be open to interpretation. But the goal here is to try to get you to the point of picking 3 consecutive sub-interface numbers. So don't pick 1, 48, and 112, right? So it's saying, hey, if you happen to pick 101, then the next 2 need to be 102 and 103. That's really what the lab is after there. Next up, the requirements for IP say that you should use the first or numerically lowest IP address in each subnet. So just to circle back to that, the diagram shows the subnet IDs. To find the first usable address, just add 1 in the 4th octet. For instance, in subnet 2, there's our first usable address, 10021, 10031, 10041 in this case. That, of course, is going to be configured on the sub-interface. Next up is probably the most complex thing to figure out in the whole lab. All right. So you go down to the switch configuration. The goal is we've got to get this router on a stick configuration done up on router 1. But what VLAN IDs do we use on each sub-interface? You might recall the sub-interface number doesn't have to match anything, but there's that encapsulation command that is the place where you configure the VLAN ID, right? So if we look at this configuration, this is straight from the lab blog post, and this is the initial config you can see there on the switch. And let's just start at the bottom. It says on interface gig 103, which is the rightmost one on the bottom, switch port access VLAN 30. So it's in VLAN 30, and the endpoint device is in subnet 4. Remember that? 10040 down here. And this next one, the config puts that port in VLAN 20, and our planning figure says, hey, that device is in subnet 3, and then this third one, it's in the attached device is in subnet 2, but there's no switch port access VLAN command. So that requires us to think back. What VLAN is it in if we don't assign it to a VLAN? By default, it's in VLAN 1. So that should give us enough information to come up with this kind of an idea. In a planning diagram, we'll have 3 sub-interfaces on the router. They'll be associated with VLANs 1, 20, and 30. And the one associated with VLAN 1 happens to be connected into subnet 2, VLAN 20 into subnet 3, VLAN 30 into subnet 4. That's the key to the whole thing. That right there. So if you didn't quite get that, go back a minute, minute and a half, rewatch that. And then you can look at it in the answer config as well. A few final thoughts before I leave you to go and do lab and implement the configuration you choose. The lab says only sub-interfaces, meaning don't configure things under the physical interface for the purposes of ROAS. It says configure both the router and switch as needed to make router on a stick work. It also tells us all the PCs are pre-configured, but you ought to check. Look at the config and make sure it matches up with your view of reality, especially on the IP parameters. And also router R1's top gigabit interface, gig 02 in this case, is pre-configured correctly. So this part of the network should work without you doing anything extra. In fact, if you get the router on a stick configuration correct on the router and switch, all 4 PCs ought to be able to ping each other. All right, so time to get to it. Here's a link to the lab. You can find most of the details on the blog page, but we've got this intro video. After you do it, if you'd like to check out the review video as well, we've got one of those. If you're new here, welcome to the channel. Hope to do a lot more of these Config Lab related videos in the future, so stay tuned for that. Subscribe and bell if you haven't already. Leave me a comment. Let me know what questions you have or what you think about the lab. Thanks, y'all. Talk to you.